Voxel budget-friendly filaments. Are they famous with a reason? And what do you think between PLA and PETG? Which one is tougher? Let's find out. Welcome to another PLA versus PETG comparison video. This is Voxel PLA Plus HS or PLA Pro, and this is PETG Plus HS or PETG Pro. The HS is probably a shortcut for the high speed. And Voxel is sponsoring many popular YouTubers, and the result is that I got several requests to test these filaments. Are they really good as they claim? I bought these filaments myself. The price is quite low, but my problem that I'm located in Europe, and for me the shipping was $90 plus some tax. But I'm lucky because I have a sponsor that's the polymaker, and I even have a budget to buy any filament I want to test. And together with my Patreon supporters, I can just buy any filament I want to test. I don't have to wait for the company if they want to send it to me or not. For both materials, they claim ultra-high flow, up to 500 mm per second speed. This is quite big speed even for the PLA, but especially for the PETG, and probably I will try to measure this. Superior reliability for both filaments, and they're also AMS compatible because they arrive on this plastic spool. Print settings for the PLA, temperature between 200 and 220 degrees Celsius. For the PETG, 230 and 270 degrees Celsius. They didn't arrive in a separate boxes, so even here they are cutting the price. This is vacuum packaging, but this is not, but probably the air only leaked in. Bags are not resealable. On the spool, similar informations like on the website, only for the PETG slightly different temperatures. For example, the maximal here is 265 degrees Celsius instead of the 270. And only two holes for locking end of the filament, and they are quite close. I like better bigger distance because if I bend it too much it will break too early. Two important informations are really missing here. One, what is the weight of the empty spool? And I will contact them as a buyer and I will see if I will get the answer. And the other is the color, because let's say we have some similar colors and I want to be sure that I want to buy or reorder a same color. In my case, this is fire orange and this is dark purple. In the meantime, I got the answer from their support. It's 200 grams approximately, more or less correct. Maybe it's a little bit more than 1 kilogram on the spool. PLA, similar, okay. I like this kind of comparison videos. It is very useful, especially for the beginner users, because we will have a direct comparison of the PLA versus PETG in the same video from the same manufacturer. And I want to break that myth that the PETG is tougher material compared to the PLA, and for this I will do more detailed impact testing on 3 different machines. Filaments go into the AMS2 Pro on Bambolab H2S 3D printer. I don't like these waves on PLA filament. They are not nice and straight, but probably for the printing this is not important. Profiles for the PLA, they suggest Bambolab PLA Tough without any changes. For PETG, Bambolab PETG HF, and only to raise the temperature to 265 degrees Celsius. These are my regular test objects, and for the impact test I will have more because I'm doing some experimenting. PLA Tough profile, most important difference is flow rate, 21 cubic millimeters per second, and the minimal fan is 80%, which I don't like. In first attempt, one of the test objects removed from the bed. The stable one, interesting. I was at the beginning of the printing, so I just stopped it. In second attempt, the horizontal shear test object removed, but this time I'm skipping that object. A little bit later, another object removed. This one is for the temperature test, so I'm skipping another one. After this, most of the parts were finished, but I noticed another removed from the bed, and this time I stopped the printing. I'm not sure, usually I have a great bed adhesion with this textured PI sheet and the PLA. It was cleaned with isopropyl alcohol, but let's check the bed adhesion. For the filling it is okay, but from PLA I'm expecting a little bit better adhesion. I did few changes in the slicer and I added some glue on the build surface, and I'm reprinting the main test objects without those for the impact test, and this time it was completely fine. Here you can see my changes. Generic PLA, which is a slower printing, and the minimal particling is also 100%. And this is picture from the camera. This is the last test subject, so it was completely fine printing this time. Even if I already have a lot of test objects, I'm curious about its mechanical properties if it is printed fast. So I'm going back to the PLA Tough profile. Only change is the glue on the build surface. And looks like it will be fine. And I will use these test objects for the testing. Printing is finished very nice, so the printability is great even on these higher speeds, only we need a good bed adhesion. And these are the test objects I will test. And I'm moving to the PETG, and I use the glue stick because the PETG may stick too good to this textured PI sheet. The start is good. This is now the 6th layer, and the speed with the PETG is incredible. I hope it will be finished correctly. Absolutely nice progress. The printing will be finished in 9 minutes. These are last two vertically printed objects, and it slowed down a little bit. This is also a critical element, but it handles it good. And it's finished. It's really nice, no stringing, properly it was dried. And bed adhesion is great, but removable thanks to that glue. Time to check the bed adhesion. Voxel PLA and PLA Basic by Bamboo Lab. Cleaning the textured PI sheet with isopropyl alcohol. And when I finished the printing of this object, I set the bed temperature to 55 degrees Celsius. And then I'm measuring the pulling force, 0.035. Miracle that it was finished at all. Switching to Bamboo Lab PLA. Printing with the same settings, 55 degrees Celsius on the bed. Pulling force 0.125. This is still low, but much better. That's why I like better 65 degrees Celsius on this surface. I think I find the reason for that weaker bed adhesion. This is PLA, and usually PLA have extremely minimal shrinking, but this is 0.12 millimeters, which is quite big for the PLA. And this is PETG. 0.14 millimeters. This is a little bit bigger, but acceptable for the PETG. Only for the PLA, usually I can measure a smaller shrinking. And probably this is the reason why it has a weaker bed adhesion without glue. It shrinks minimally, especially with this additional cooling, and then it shrinks and removes. I noticed on the smaller test object the difference is not big. 19.97, 19.95. Let's measure that ultra high flow. I'm preparing the test from 10 to 40 cubic millimeters per second, and using this step the object will be exactly 60 millimeters. With this it's easier to calculate the flow from the height. And here you can see the preview switching to the flow from 10 to 40. Stock X1 carbon texture PEI with the glue on it, and as you can see, don't want to stick to it. Good old engineering plate with the glue on it. Everything sticks to it. There is no filament which I couldn't print with this plate. And do you know that it is available for the H2 printers? And I already bought one. The printing is at 65% and looks completely okay so far. Printing is at 73% and I think I will stop the printing. There are signs of under extrusion. But even this bed adhesion could be a little bit better. PLA Basic, I hope it will be good for the comparison. Printing at 65%. I could hear a few skips of the extruder, but visually the printing looks okay. Printing at 76%. Now I can see some serious under extrusion, so I will stop the printing and I will analyze them. And just to show you the difference in bed adhesion, well, I cannot even remove it. I have to wait until it cools down. PETG 67% and looks like PLA so far. Print temperature 265 degrees Celsius. Printing at 85%. Two PLA printings are stopped far before this. Of course I can see some under extrusion even here, but I will leave it so far. I can hear quite big clicking of the extruder. Probably I have to stop it soon. Ah yes, okay. These tests are not too healthy for the hot end. Theoretically, I should stop it immediately when I see some under extrusion. Until this point 18 mm the quality is great, and until this point 26 mm the quality is acceptable, but I could measure some minimal under extrusion. And with PLA Basic these numbers are 24, great extrusion, and 27, acceptable. And in this case, great until 26 mm and acceptable up to 40 mm. These are those heights, and this is that flow rate at that height. And more or less for all three filaments, I will set, let's say, 20 cubic millimeters per second flow. That's almost in a safe zone. And these are those speeds if I calculate with 0.4 millimeter nozzle and 0.2 millimeter layer height. Don't be confused. Orca Slicer set the line width to 0.7 millimeters for the test. The reason for this is to reduce the speed, so it will not stress the printer with the speed, because this is the flow rate test. And these are the temperatures I use in this test. Does it mean that we cannot really print with 500 millimeters per second speed? Well, we can, but not with 0.4 millimeter nozzle, let's say with 0.2. That's why more serious is if the company gives the maximal flow rate, but also important to give on some stock specific printers, for example Bamble X1 Carbon or Prusa Core 1 and similar. Tensile test with horizontal printed objects, PLA, PETG, I already mentioned that I will include here the average PLA and PETG filaments. Now we can see the PLA compared to the PETG is noticeably stronger, and this PLA is stronger even compared to the average PLA materials. The PETG it is noticeably weaker compared to the average PETG. Layer adhesion test, vertically printed objects, PLA and PETG. These PLA have fantastic layer adhesion. Here you can see my rating table for this test object. All other three are very similar. Now, interesting thing I noticed, these high flow filaments will melt better and looks like they will bond better to the layer below. So maybe this is the reason for the better layer adhesion. And it is nice to see this great value. Shear test horizontal objects, side by side two materials. Vertically printed objects. Printed in horizontal position, PLA is stronger compared to the PETG, but this rate is typical for the average PLA and PETG materials. Now, printed in vertical position, the layer adhesion is very important, and thanks to this the PLA is extremely strong here, stronger than PETG, but this PETG is stronger compared to the average PLA and PETG together. Only pay attention that I have only few test objects here, because I started this testing type much later. Torsion test objects printed in horizontal and vertical position. I'm starting with horizontally printed test objects. 1.7. Loaded 90-degree rotation. 1.8. The maximal load. 1.3. Printed in vertical position. The maximal brake load. 1.1. Yes, different brake types between horizontal and vertically printed objects, but what was interesting that this one printed with PETG, I could make more than 90-degree rotation, which is very rare. Loaded 90-degree rotation, PLA again stronger compared to the PETG, but again this PLA is stronger to the average PLA. Printed in vertical position, the maximal load, here the layer adhesion is important, and again no surprises that this Voxel PLA is the strongest. And interesting, all three more or less very similar. 3-point bending test, side by side two materials. Distance between supports is 50 mm, and I'm measuring the deformation after 1, 30 and 60 seconds under these loads. And this is the deformation under 10 kilograms. Visually no permanent deformation on them, not even on the PETG. Typically we can see more deformation on the PETG filaments compared to the PLA filaments, but pay attention to this 10 kg deformation. This is the average PLA and this is the Voxel PLA. We can see much less deformation during this 1 minute compared to the average material. Creep test the deformation under constant load, PLA and PETG. Wow, more deformation on PETG. 15.05, 18.10. Day 5, last day of measuring, 17.85, 20.19. Visually, the permanent deformation is very similar. On this graph, we can see the distance between two reference surfaces, and we can see more deformation on the PETG compared to the PLA. Now, the creeping is the difference between 2 days. Now, in my summary table, I am recording only first 2 days. I started collecting all days much later. But let's see the creeping, the difference between 2 days. And we can see that this Voxel PLA has similar creeping compared to the average PETG materials, because this is the typical creeping for the PLA. Temperature test in the oven, and two on the right side are the Voxel PLA and PETG filaments. And I want to record the temperature of the first deformation, and no big surprises here. The PLA started at 57, PETG around 71 degrees Celsius. And I just check how hard they are. And more or less this is typical for these materials. This is the main advantage of the PETG materials compared to the PLA, and the Voxel PLA and PETG started with deformation on just a little bit higher temperatures compared to the average PLA and PETG. Impact test on my DIY equipment. This is PLA slow motion, side by side 3 measurings, still PLA. And this is the result, edge positions of the hammer after these breaks. And now this is PETG, one slow motion video. All 3 side by side. And the result, and we can see this is more brittle material. Now moving to the digital testing machine, ISOD. PLA slow motion. Moving to the PETG. Still slow motion. And this is the result for the PLA and for the PETG. Moving to the sharp impact testing, replacing the hammer. Side by side all 3 for the PLA. And this is PETG. The result for the Sharpie PLA. I don't really understand. I had 3 measurings with the PETG, but here on the screen I can see only 2 numbers, but they are very close to each other, so I will use only these 2. The result of my DIY impact tester, and I'm including here the average PLA and PETG. This is the ISO digital and the Sharpie digital. And all 3 we can see on this table or on this graph. And we can see that the PLA is a tougher material compared to the PETG. Look at this, and I saw this so many times. Now this PLA is more brittle compared to the average PLA, but here many crazy PLA types are included, like, I don't know, Super PLA Plus by Overture or similar. The PETG is typically more brittle, so this PETG is tougher compared to the average PETG. And with the brittle filaments, I'm getting more or less very similar numbers with the digital ISOT and the Sharpie. Of course, this is completely different test type, but with the brittle materials, similar values. All results one more time without any additional comments. And these 2 lines will be added to the summary table for my Patreon supporters as my only gift for them. Result for the bending test: deformation after 30 seconds, deformation after 130 and 60 seconds, torsion test, temperature test, and all impact tests. About that person who designed this spool, I would force him to insert and take out this filament 100 times. Maybe he would understand what is the problem with these holes for locking end of the filament, and he would add more holes on bigger distance and bigger diameter holes. I mean, this wouldn't cost more in the production, and they would show that they care about the customers. I mean, somebody has to mention this, because maybe they don't even know about this problem. And just for example, this is the correct design of the holes. Again, this was much bigger work than I planned. First, about PLA filament. This is a quite good PLA filament, mechanical properties above average PLA. The only thing what I don't like here, except the spool I already mentioned, is that I don't have that nice adhesion to the bed. About the flow rate, it is better than average PLA, something similar like a Bamboo PLA Basic, but not 500 mm per second speed. Of course, I can imagine some setup where it can reach 500 mm per second, but that's not average setup. About PETG, let's say average mechanical properties, but what I like with this material is that it is able to be printed on really high speeds and high flow rates. Again, not really 500 millimeters per second, but even then much higher than average PETG. Okay, so if you are located in USA, then I can recommend really these filaments. And if you have some other experience with these materials, feel your lines down in the comment section. Thank you for watching this video until the end, and happy printing.